Hi everyone, in this video I wanted to go over this DIY separations lab that we'll be doing this semester. So this will not actually be due until the end of the semester, but I wanted to go ahead and go over the instructions with you. That way we're all on the same page, but as you do have a rough draft that's due a little bit earlier, although the final report won't be due till the end of the semester. So I've gone ahead and put this just in the generic lab folder, and so you'll come down and you'll see this DIY separation lab, and I've gone ahead and put a few things in here for you. So the actual instructions themselves, a place to turn in your rough draft, and then a place to turn in the final report. So really what I wanted to go over with you is the instructions for this and exactly what is this project. So the reason it's called DIY, or do it yourself, is because for this one you're going to be designing the experiment. So you will design the procedure, you'll write up the lab report sheet, just like the ones I've been giving to you, and then you'll design the actual experiment, and then in the end you will perform the experiment to see if what you wrote was a good technique or not. Okay, so a couple things here. So what is the objective? So the objective is to design an experiment to separate a mixture of sand and salt using the solubility principle and accurately calculate the percent of the salt in the mixture. So in other words, you're going to make a mixture of sand and salt, then you will separate them using solubility, and then you're going to calculate the percent of salt. So how much of the mixture was salt and how much of it was sand. So you're going to write the procedure, and you're going to write a report sheet. And then lastly, you will perform the experiment to check for the quality of the procedure and the report sheet. Okay, so let's go over the elements that should be in your report. So I'm just going to go through these one by one, and we'll talk about a little bit about them. And then once I'm done going each part with you, I'll talk with you about a little bit about how you might go through this experiment. Okay, so the first thing you want to put is a title. So every good experiment has a title, so you can write something simple like the separation of a salt and sand mixture, or you could write something like the determination of the percent composition of a salt and sand mixture, something like that. Just, come up with this on your own. It can be really anything you want it to be, but it should describe the experiment so that if all I read was the title of the experiment, I'd have a good idea what you were doing. And then make sure you do go ahead and include your name as the author, since you're the one writing it. Okay, the next thing is the objective. So what is to be accomplished by performing this experiment? So is the idea to calculate the percent of salt in the mixture, or is the idea to gain understanding through separation techniques? What are you looking to convey by giving the student this experiment? And that can be just one sentence or just a brief explanation there. It doesn't have to be real long. Next thing, the introduction. So explain why the experiment is important and include any information that is pertinent to assist with the understanding the concepts that will be used, including formulas. So in other words, what techniques am I going to use? Why am I doing these techniques? What's the purpose of, if I'm decanting something, what's the purpose of decanting? Why am I doing that? And then as far as explaining why it's important, what is the student or the person doing the experiment getting out of this, and why is that important to them, or why should that be important to them? And this doesn't have to be huge, but it should be 3 to 5 or more sentences. You can kind of take a look at the experiments we've been doing to get a good idea of how long each of these sections should be and what kind of should go into them. Next thing, learning objectives. So what skills will be utilized in the experiment? So they could be everything from the lab skills to the calculations themselves. So what skills will the student be using? The next thing is the equipment and chemicals. So what pieces of lab kit do I need? So do I need a Bunsen burner? Do I need a hot plate? Do I need a beaker? What kind of things do I need to do the experiment? And that includes the chemicals. So obviously, if I just gather up all my glassware and equipment, I still can't do the lab without having the correct chemicals. Okay, so make sure you list everything there, even including something like, do I need water for the experiment? Okay, so think about someone that was doing this, just in a lab somewhere, and they need to have everything they need to the experiment, including the chemicals and including all of the equipment. Okay, the next one, procedure. So instructions on how to perform the experiment. Okay, so obviously if someone's going to do this experiment, they have to know the steps to do it. Okay, so do I need to, weigh something out? Do I need to mix something? Do I need to heat something? Anything that needs to be done in order to complete the experiment should be included in the procedure. And that includes anything from, as I said, weighing out the salt in the sand in this particular case, to adding it to a beaker, to gathering water. Anything that you need to do to complete the experiment should be here. And you want to try to think about this as step by step as you possibly can. So if you cook and you follow recipes, kind of think about it in terms of those. If a recipe didn't tell you to do a certain step, it can completely ruin the dish. So you need to make sure that every step is there with enough explanation that someone that hasn't done the experiment before could actually do the experiment. So, if there's a special technique, you may want to spend a little more time describing it. But in general, you just want to put all the steps here. And it says instructions for preparing any solutions. So if, for instance, they need a 50% alcohol solution or something like that, make sure you include the instructions on how to prepare that. That might not be so relevant for this experiment, but if there is anything like that you need to prepare, such as a mixture or a solution, make sure you give instructions for those. Okay, the next thing will be the report sheet. So, of course, data tables for collecting the data. Any required calculations. So, for instance, in this experiment, calculating the percentage. It says include a minimum of 3 questions to be answered about the experiment. At least 2 should have questions that require using the data to justify the answers. So 3 questions about the experiment. So one could be just simply looking for error, experimental error. But at least 2 should say, have answers coming directly from the data. You can come up with those on your own, but make sure that you need the data to justify the answer. And the last thing, how will the student know if their results are accurate? So can you, for instance, do I know how much salt and how much sand actually went into the mixture? Because if I know that, then I can calculate the theoretical percent composition, and then I can calculate my experimental percent composition. I can compare those. So something like that. It doesn't have to be what I'm saying. I'm just trying to give you an example of how you might know whether your results are accurate or not. Last thing, references. Any references you might have used in writing the report. So if you do, look online and find some source that helps you along, make sure you include those. The more reputable, the better, obviously. You don't necessarily want to use something like Wikipedia, but just include whatever it is that you use. Okay, so those are the elements that I would expect to find in the actual experimental sheet. So everything I need to do and answer in the lab should be included in that sheet. Okay, and what you will do, I'll get to this at the end. So, it actually is the next thing on the list. Good. So what you'll actually do is you will write this first part out, and you will give me the rough draft. So you need to, at least at the very minimum, include the procedure. Okay, so that I can see what it is you're planning to do. A, to make sure that it's at least decently safe. And B, make sure that I think it will work. So that you don't go through with the experiment that's not going to work. Okay, so you're going to write a rough draft of what the experiment will entail, and then submit that to me, and include any references. So that's why I have that slot there for you to turn in a rough draft. Okay, so just give me a rough outline, at least an outline, of what you're planning to do, so that I can make sure that it's going to work for you, and that hopefully nothing will go wrong. Okay, so that's going to be due at the end of the 5th week, so I think I have it due the Monday after the 5th week, just since our due dates have always been on Monday. That way, you guys always have the weekend to do things, since I know a lot of you guys work. Okay, but that will be due essentially the Monday of the 6th week. Okay, so it says proceed with the experiment once I've approved it. And then perform the experiment and turn in the report sheet with the collected data and answered questions. And that would be due at the end of the 7th week. And again, I basically made it due at the first Monday of the 8th week. Okay, it says include any images of the relevant steps and make sure you're shown in the images, just so I can see that you're the one that did it. Okay, then it says analyze the experiment and write up a critique on what could have been improved. Remember that science is about learning from mistakes. So, in other words, basically write a conclusion section. That's what I would do, I think, is write a conclusion section that, talks about what went right, what went wrong, and just kind of shows, like, do you think your experiment went well? Do you think it not went well? And if it didn't go so well, what didn't go well? And if it did go really well, what steps do you think were important to making it go well? So this 5th step, I would basically, I think, just write a conclusion section in my report. That's what I would do. Because I think that's, or if you want to, you could also include that as a separate document. That's totally okay too. Okay, so the last thing I wanted to talk about here was just a little bit about how you might write this procedure. So if we think about the solubility of salt and sand, that's the best starting point. And to do this, there's numerous of these types of experiments you can find online to get a good idea of what steps you should do. But we can also just think this out on our own. And you may have even done an experiment like this before. So if we think about salt and sand, so salt, we just mean sodium chloride in this case. What's something that would dissolve salt but not sand? So think about the beach, right? So the beach, we know, nice and sandy, and we know that the water does not come and just dissolve all the sand from the beach, right? And then if we think about, okay, the ocean water is salty, right? So we know that salt is soluble in water, which we probably already know these things already, just intuitively. So I'm just kind of giving you an example of, if you weren't sure about this, what's a way I could think about it? Okay, so using that analogy or those ideas, how could we separate salt from sand? Well, obviously one way would be to add water and to do an extraction. And by extraction, I mean dissolving the salt into the water, and then somehow separating the sand from that new solution. So we could do this either through decantation, that could be a way to do it, which just means basically to slowly pour the water from the solid and leave the solid from behind. We could do it through filtration and then drying. Okay, so somehow we need to separate the soluble product from the insoluble product. And that can be through filtration, as I said, decantation. There's lots of ways we could do this. Okay, but now once we have those two separated, how do we get our salt back? So we need to get rid of the water somehow. And there's a couple of ways you could do that. So obviously you need to evaporate the water. And you could choose to do it slowly by simply leaving it out on the counter. So you have a beaker, you leave the salt and water mixture in it, leave it for a few days, you come back, the volume is greatly reduced, and maybe you can finish it off with a little bit of heat. Or we could simply place it on a hot plate and slowly boil the water away until we're left with just the salt. Okay, so those are just a couple examples of how you might separate the salt and the sand, and you can come up with another on your own. That's perfectly fine too. I'm just trying to give you some idea of how you might go about this. And then once you have them separated, keep in mind we need to know the masses of these. So if I, for instance, put my saltwater mixture into a beaker and then evaporate all the water away and I'm left with just the salt, well, it would be much easier if I knew the mass of just the clean beaker, because then the difference between the beaker with the salt and the clean beaker would give you the mass of the salt. Same thing with the filter paper. If I know the mass of the filter paper, and then I can dry the filter paper, and I can either scrape the sand off the filter paper, or I could weigh the whole thing together. And to do that, I need to know the mass of the filter paper. Or I could do it with a beaker. So if I was decanting, for instance, I would need to know the mass of the clean beaker before decanting the water out of it. Okay, so there's lots and lots and lots of ways you can go about this. That's just what I wanted to point out is a few of these ideas of, maybe using water to do an extractant or some other solvent would be fine too. Water is probably the easiest. The only bad thing about water is it's hard to evaporate, so maybe you could think about something that would be easier to evaporate. Okay, but that's what I want you to come up with. So I'm not going to talk too much more about it because I want to see what you guys come up with. So again, you can go online and help and find other experiments that are similar to help guide you. But in the end, make sure you are writing this yourself. And then you will submit that rough draft to me. And I will go over your procedure just to make sure, like I say, make sure it'll work for you. And make sure it'll be safe. And then you can finish up the report and turn it in to me. Okay, so I think I'm going to end this video here. If you do have questions about this, I would strongly advise starting on this early, this week or next week at the latest, and then trying, to communicate with me if you really have any trouble. Okay.